Consumers often fear ingredients that sound like chemicals. Often they do not understand the purpose of the ingredient in the food product. Monosodium glutamate, or MSG, has a bad reputation, yet few people understand the purpose and efficacy of it. Commonly, MSG is used as a salt replacer in Chinese foods, chicken broth, chips, and other food products. By utilizing MSG in replacement for table salt, producers are able to engineer lower sodium products without a compromise in taste. Sodium consumption is a major problem in the United States. According to the American Heart Association, Americans eat, on average, more than 3,400 milligrams of sodium each day. The recommended sodium limit is 1,500 milligrams. The purpose of my experiment was to test whether it was possible to make low-sodium marinade for beef steak that consumers enjoyed. In this video, I will give you the background, methods, materials, results, and conclusions of my experiment. This is the chemical structure of monosodium glutamate. MSG, or monosodium glutamate, is the salt form of glutamic acid. The only difference between MSG and glutamic acid is that MSG has a sodium ion on the oxygen of the carboxyl group on the right. MSG is utilized in various low-sodium food products as a flavor enhancer. Over the years, there has been heated debate as to the safety and efficacy of MSG in our food supply. According to the United States Food and Drug Administration, MSG is categorized as a generally recognized as safe, or GRAS, substance. MSG is known as an umami element. According to the Merriam-Webster Dictionary, umami is defined as taste sensation that is meaty or savory and is produced by several amino acids and nucleotides, such as glutamate and aspartate. Adding MSG to low-sodium food products can boost consumer approval. In a study conducted by the Journal of Food Science, scientists asked participants to taste reduced sodium chicken noodle soup with MSG and low-sodium chicken noodle soup without MSG. Consumers rated the MSG soup as more flavorful and savory. This is important because food producers can create low-sodium products without compromising taste. Following digestion, glutamate is absorbed into the GI tract and broken down in the intestine, stomach, and colon. The catabolic products of glutamate discharge ATP and CO2. Glutamate that is not metabolized enters the hepatic portal circulation where it is metabolized in the liver and generates energy. Glutamate, regardless of source, is metabolized and absorbed the same way. Obviously, the safety of any food product depends on the purity level, the amount used, how it is administered, in addition to the food component it is ingested with. And MSG is no different. When it is administered subcutaneously in animal subjects, MSG produces retinal and hypothalamic lesions as well as abnormalities in hepatic fat metabolism. However, normally ingested MSG does not cause any hypothalamic damage, retinal lesions, or alterations in hepatic fat metabolism. Furthermore, the amount of MSG needed to produce adverse health effects is not feasible in humans due to extreme nausea. I conducted an experiment to examine whether individuals preferred steak marinated with table salt or steak marinated with MSG instead of table salt. I also asked participants to rate the salt and flavor intensity of each steak. I hypothesized that people would prefer the steak marinated with table salt. A random sampling of undergraduates were asked to try two different marinated steaks, one prepared with table salt and the other with MSG. The steak was cut into pieces and de-identified with a random 3-digit number. Here is a list of all the equipment and materials you would need to conduct this experiment at home. Here is the recipe for making the control. You're going to combine all the marinade ingredients and whisk. Pour the marinade into a large resealable plastic bag and place the beef steak inside. Allow the beef steak to marinate in the refrigerator for about 2 hours. Remove beef from marinade and then pan fry. Here is the recipe for the experimental steak. You will use exactly the same ingredients as for the control, except for instead of using a teaspoon of table salt, you'd use a teaspoon of MSG seasoning. Statistical analysis was done on the data, and using a paired t-test, I found a p-value of 0.00262, which the conclusion would be that the steak with table salt was rated as saltier than the steak with the MSG. And here is a box and whisker plot that is illustrating the same point. Again, participants were asked to rate the salt intensity of the beef steak, and you can see over here on the left we have the steak with the MSG. The average salt intensity was much lower than for the steak with the table salt, which is over on the right here. The average salt intensity was a lot higher than that with MSG. A statistical test was done on the flavor intensity of the steak with MSG and table salt, and the conclusion was that there was no difference in the flavor between the steaks. The p-value was 0.09. And then you can see here also with the box and whisker plot that the difference in flavor intensity of the beef steak seasoned with MSG versus table salt was basically the same. The table salt was a little bit higher than the MSG. The participants were then asked to rate each steak using a hedonic scale, which is just how much did you actually like each steak. On the left here you see the beef steak marinated with table salt, and the participants rated the steak as like a great deal the most. That's the bottom bar on the bar graph. And then on the right here you see the beef steak marinated with MSG, and you see a similar spread. The majority of people saying that they liked the steak with MSG a great deal. Finally, the participants were asked which sample did you prefer, and 6 people responded that they preferred the table salt steak over the MSG steak, and 5 people said that they preferred the MSG steak over the table salt steak. Overall, using a preference test, I found a p-value of 1.0, which means that one sample was not preferred over the other. And here is a pie chart that's illustrating the same point, that there was basically an even split between people that liked MSG over table salt and people that liked table salt over MSG. So overall, the conclusion would be that one steak was not preferred over the other. The conclusions of my experiment agree with previous studies on utilizing MSG in replacement of table salt. The original hypothesis was that participants would prefer the steak marinated with table salt. Overall, there was no difference in preference. Consumers stated that they did not prefer the steak with table salt more than the steak with MSG. Furthermore, the data also indicates that there was no difference in flavor intensity between the two steaks. Participants were asked to rate each steak using a hedonic scale. Both steaks were rated as like a great deal the most. This was not the result that was expected. It was predicted that people would prefer the steak marinated with table salt. The results indicate that while participants were able to distinguish the difference in salt intensity between the two steaks, no difference was extricated in flavor intensity or overall preference. Overall, the conclusion of this experiment is that MSG can be used in replacement of table salt to produce lower sodium food products without a difference in taste. This experiment can help convince both food producers and consumers alike of the efficacy and benefits of utilizing MSG in replacement of salt in food. Thank you for watching.